Welcome to the Deep Dive, where we cut through the noise and get to the core of what you need to know. Today we're plunging into, well, one of the most urgent and frankly mind-boggling conversations of our time. How we might actually engineer our way out of the climate crisis. With global temperature still climbing, the idea of directly manipulating our planet's climate is shifting. It's moving from science fiction, really, into serious discussion. Okay, let's unpack this.
We definitely should. What we're really diving into today is solar geoengineering. You might also hear it called solar radiation management, or SRM. Basically, these are hypothetical technologies, ideas designed to counteract global temperature rise. How? By reflecting sunlight away from Earth. But it's crucial to understand this isn't like carbon dioxide removal. SRM technologies, they don't directly reduce the greenhouse gases already in the atmosphere. Which means, and this is important, they wouldn't fix critical issues like ocean acidification. You know, the ocean getting more acidic from absorbing all that CO2, which really threatens marine life, coral reefs, shellfish.
Right, so it tackles temperature, but not the root CO2 problem or its other effects. And our mission for this deep dive, then, is to explore 6 of the, let's say, most prominent solar geoengineering proposals. We'll look at their potential, yeah, but also their challenges and the bigger picture implications to the planet. And given how controversial these ideas are, our goal is really to give you a comprehensive, balanced understanding of what they actually involve. What's really striking is how fast these concepts seem to be moving, from just theory into, well, almost the real world. We're seeing scientific meetings, even discussions in the U.S. House Subcommittee. Yeah. It feels much more tangible now.
It really does. And look, while the vast majority of scientists agree, absolutely agree, that cutting global greenhouse gas emissions is paramount. That's the main goal. The reality is, those emissions are still rising. So some researchers are pushing harder now for more investigation into these, let's call them controversial side measures. But as you said, this growing interest, it's met with pretty significant resistance and real fears, worries about potential environmental impacts, societal challenges, things that could maybe in some scenarios be even worse than climate change itself.
Okay, so let's get into these proposals. It's fascinating. Even though they share that goal, limiting sunlight, you'll see that very wildly in how they approach it. You've got these grand global schemes on one hand and then much more localized efforts on the other.
Exactly. The first one, and probably the most discussed, is stratospheric aerosol injection, SAI for short. This involves spraying aerosols, tiny particles like sulfur dioxide, maybe sulfuric acid, or even hydrogen sulfide high up into the stratosphere. We're talking planes, high-altitude balloons, that sort of thing. The mechanism is actually quite similar to what happens naturally after huge volcanic eruptions. Remember Mount Pinatubo back in '91?
Vaguely, yeah. Big eruption.
Huge. And it caused a global cooling about 0.5 degree Celsius for maybe 2 or 3 years, all because of the aerosols that shot up there. And scientists like Dr. Anthony Jones confirm, yeah, in injecting aerosols like that, it seems pretty effective at cooling.
Wow, replicating a volcano basically on command.
Yeah.
Kind of mind-boggling. So, okay, beyond just that cooling effect, which is dramatic, what are the potential upsides scientists are looking at?
Well, besides significant global cooling, some research suggests it could also help bring global rainfall patterns maybe back towards pre-industrial averages. And what's interesting, too, is it seems quite effective at reducing certain extreme weather events like heat waves and those really cold nights over land. And there's always a but with Earth systems.
Yeah, the cooling sounds amazing, but I was waiting for the but.
Yeah.
Knowing how complex everything is, there must be some serious downsides, right? What are the big worries here?
Oh, absolutely. The concerns generally fall into a few main buckets. First, regional impacts. That's a big one. Like if you only injected aerosols in the northern hemisphere, models suggest it could mess with rainfall, maybe increase drought risk in places like India or the African Sahel. And depending on exactly how you did it, it might reduce storms in the North Atlantic, or it might actually increase their frequency or intensity. It's complicated. Then there's this really severe risk they call termination shock.
Termination shock.
Yeah. Imagine you're releasing these aerosols, cooling the planet, and then suddenly you stop. Maybe because of a political disagreement or an attack. Who knows? Global temperatures could shoot back up really fast. Studies suggest that would be, well, catastrophic for wildlife.
Right.
Now, some researchers think this risk might be a bit overplayed, maybe manageable if you tapered off slowly or had other things like carbon removal running alongside, but it's a major concern. And then you've got worries about acid rain because that sulfur has to come down eventually, plus potential damage to the ozone layer. As Dr. Ben Kravitz puts it, this stuff mostly only exists in the modeling world. There's just so much we don't know.
So many unknowns, serious risks.
Yeah.
How close are we realistically to something like SAI being actually feasible? Is the tech there?
Technologically, it's not a massive leap, surprisingly. We have aircraft that can reach the stratosphere. Now, existing planes might not be able to carry enough stuff for a sustained, large-scale operation, but the basic capability is there. In fact, Harvard University has this planned experiment, ScopeX. It's meant to be one of the first real field experiments, a small step into real-world testing.
Okay, so that's the global aerosol approach.
Yeah.
But you mentioned localized options, too. What if we could be more targeted?
Yeah.
That brings us to the second idea, right? Marine cloud brightening. Sounds like it offers a different kind of control.
It does, potentially. The idea here is you have ships out at sea spraying fine saltwater mist up into low-lying clouds. These salt particles act as cloud condensation nuclei, little seeds, basically, for water vapor to condense onto. This makes the clouds form more droplets, become larger, brighter, and so more reflective to sunlight. Models suggest it could cool the planet, maybe, but also it could potentially be used very specifically, like over areas needing protection, say coral reefs, or maybe deployed in the Gulf of Mexico to try and weaken hurricanes. Some even theorize it could help restore temperatures and ice cover and fight coral bleaching.
That sounds incredibly targeted, maybe even helpful for specific vulnerable ecosystems like reefs.
Mm.
But localized effects, do they bring their own problems?
They certainly could. Professor Douglas McMartin points out that it has a large and very localized effect, which means you get much more regional variation in the climate response compared to something widespread like SAI. And that variation, well, it could potentially upset weather patterns, ocean circulation, and local biology. You might end up with bad weather somewhere else or less rain in certain areas. And honestly, scientists still don't know exactly where and when this technique actually works best. That makes predicting the global impact really tricky. Despite all that, Australia is actually running some local experiments right now, trying to protect parts of the Great Barrier Reef.
Yeah, what strikes me with these first two, SAI and rain cloud brightening, is this fundamental tension. Global scale versus highly local. It's not just a technical choice, is it? It feels profoundly geopolitical, too.
Yeah.
Okay, so from those really high-tech, large-scale ideas, let's bring it back down to earth a bit. Literally, the next proposal feels almost low-tech by comparison, and something maybe we could do right now. High albedo crops and buildings. Albedo just means reflectivity, right?
Exactly. High albedo means highly reflective. And yeah, this is much more grounded. We're talking about simple things like making rooftops and walls brighter, just painting them white, for instance. You see this already in hot climates. Think of those white villages in the Mediterranean, like on Santorini. And you could potentially apply similar ideas to crops, maybe breeding or genetically engineering plants to have a slightly waxier, shinier coating. Now, this probably won't make a huge global difference on its own, but locally, it can significantly cool things down, especially in cities during heat waves. And for crops, it might help decrease local and regional temperatures, particularly when it gets really hot.
So more of a local fix.
Yeah.
Which sounds, I guess, inherently safer, less likely to cause those big termination shock issues or spark conflicts across borders.
Precisely. The smaller scale generally means lower risk of those big, scary problems, like cross-boundary conflict or termination shock. You can kind of limit the effects regionally, but, there are always trade-offs. For crops especially, you'd need to weigh any cooling benefits against potential downsides, like maybe impacting how productive the crops are.
Right. Okay, now we're moving into slightly more theoretical waters again. The next two, the ocean mirror and cloud thinning. Let's start with the ocean mirror. What's that about?
Okay, the ocean mirror concept. Imagine a fleet of ships out on the ocean. They're designed to churn up millions upon millions of tiny microbubbles right at the surface. This creates sea foam, which is much more reflective than the dark ocean water, maybe 10 times more reflective. So it bounces sunlight back into space, cooling things down. Professor Julian Evans points out a potential advantage here. If something goes wrong, you can just stop making the bubbles.
So it can be shut down fast.
Exactly. The bubbles just burst, and the effect disappears pretty quickly. Now, some early research back in 2010 raised concerns. Could it reduce sunlight getting down to marine ecosystems, affecting tiny plants, the primary producers? But interestingly, more recent modeling suggests maybe not. It had found no significant effect on ocean primary productivity. A potential challenge, though, is the energy needed. Keeping those bubbles going for days or weeks could take a lot of power.
Okay, interesting. Bubbles reflecting sunlight. Now, what about cloud thinning? You mentioned cirrus clouds specifically. That sounds like we're getting really specific with the atmosphere, almost like atmospheric surgery.
It kind of is cirrus clouds. They're those thin, wispy ones, really high up, made of ice crystals. Now, they do reflect some sunlight back out, but they're also really good at trapping the long-wave radiation, the heat rising from Earth.
Yeah.
So their net effect overall is actually warming the planet.
Wait, the clouds themselves cause warming more than CO2?
Well, the total warming effect from all existing cirrus clouds is actually thought to exceed the warming caused just by the extra CO2 we've added since pre-industrial times. It's significant. So the idea with cloud thinning is, well, to get rid of them or make them dissipate faster. How? Maybe using drones to inject tiny solid particles like desert dust or even pollen into the clouds. These act as seeds for the ice crystals to grow on, making them heavier so they fall out faster, thinning the cloud. Professor Ulrich Lohmann suggests that if you could remove all cirrus clouds, it could potentially offset more than the warming caused by a doubling of CO2.
Wow. That's huge potential, but
Big risks again. What if you get it wrong? What if you overseed the clouds? You could accidentally make them thicker and more persistent, causing even more warming. Plus, there are huge questions about how this would affect overall atmospheric circulation, what it would cost, and if it's even feasible on a large scale. Lots of unknowns.
okay, and that brings us to the last one. The most technologically ambitious, maybe. The one that really feels like pure science fiction. Space sunshades. Giant mirrors in space.
It really does sound like sci-fi, doesn't it? But yeah, that's the concept. Sending a massive mirror, or maybe a whole fleet of smaller mirrors, into orbit, either around the Earth or maybe out at a stable point between the Earth and the Sun. The goal is simply to block a small fraction of incoming sunlight before it even reaches us. Professor Govindasamy Bala notes that reducing incoming sunlight by just about 2% could potentially offset the warming expected from a doubling of CO2 levels. Going from about 280 parts per million pre-industrially up to 560 ppm. We're currently around 400, maybe a bit more now.
Just 2%, but the challenges must be astronomical, literally.
Oh, absolutely immense. It's a huge technological
Yeah.
challenge just getting something that big up there and keeping it positioned. And you'd need to constantly adjust it or add more shielding as CO2 levels continue to rise. While it might be the least disruptive environmentally, because the intervention happens out in space, it's considered prohibitively expensive compared to other SRM ideas. And it definitely requires the most advanced technology of all the options we've discussed.
Right. So looking across these 6 ideas, wow. It's a spectrum, isn't it? From aerosols high above us to brightening clouds, painting roofs, making sea foam, thinning clouds, even giant shades in space. What we've seen is this range from maybe feasible planet-scale stuff down to really local, almost immediate actions. And each one forces us to grapple with a totally unique set of trade-offs. Energy use, unforeseen side effects, regional winners and losers. And this is where it gets really interesting, I think. Beyond the tech, the core debates, the huge challenges surrounding actually doing any of this.
Exactly. And probably the biggest debate is this substitute or supplement dilemma. There's a real fear among many scientists and observers that solar geoengineering could be seen as a quick techno-fix.
A magic bullet.
Kind of. A dangerous magic bullet, maybe. One that could divert attention, resources, political will away from the absolutely essential job of cutting greenhouse gas emissions. Professor Bala warns exactly this. It might allow CO2 to build to dangerous levels in the atmosphere while we're just masking the warming. But then you have other scientists like David Keith who argue very strongly that it's at best a supplement to emissions cuts, not a substitute.
Yeah.
Their view is more like, okay, we need emissions cuts and we need carbon removal, and maybe, just maybe, solar geoengineering carefully deployed could lead to a significantly safer climate overall than relying on cuts alone, especially if cuts are too slow. There was actually a paper by McMartin, Keith, and Rick that showed how SEI could potentially be used. They modeled using it to limit warming to 1.5 degrees Celsius by 2100. It involved peaking at around 5 million tons of SO2 sprayed per year. But, and this is absolutely crucial, hitting 1.5 degrees using SEI would not be the same environmentally as getting there just by cutting emissions.
How so?
Because it doesn't lower the CO2 concentration itself. So you still have ocean acidification. And you don't get the co-benefits of ditching fossil fuels like cleaner air. It's just managing the temperature dial. It's a really complex trade-off, isn't it?
It really is. It hammers home that it's not just about hitting a temperature target, but how you get there matters enormously. So, okay, if we even contemplated using these technologies, what does this all mean for who decides and how? I mean, governing this stuff.
Yep.
It seems almost impossible. Who gets their hand on the global thermostat?
You've hit the nail on the head. The governance conundrum is, well, monumental right now. There are basically no clear policies, no international laws saying who could do this, who regulates it, who's liable if something goes wrong. Most of the research is concentrated, US, UK, Europe, China. But there's a really strong push, especially from scientists and policymakers in the global south saying, hang on, developing nations need to be leading the research and evaluation here.
Because they're often the most vulnerable to climate impacts.
Exactly. They have the most at stake. So initiatives like SRMGI, C2G2, they're working hard to try and broaden the conversation, get more participation globally.
But getting global agreement on something this potentially world-altering. I mean, look how hard it's been just to agree on cutting emissions.
It's incredibly difficult. Janos Pastor from C2G2 put it starkly. He said developing global governance for this would require more global cooperation than has ever been attempted before, ever. Professor Alan Robach basically asks, if the world can't even agree on mitigation, how on earth could we agree on geoengineering? Dr. Anthony Jones says he finds it very difficult to imagine a scenario where all countries agree on exactly how much geoengineering to do and where and when. And Dr. Joshua Horton really emphasizes it's not just one problem, it's a whole complex of problems you have to solve simultaneously. Moral hazard, the risk of reducing the incentive to cut emissions. Decision-making, who decides. Democracy, how do populations consent. Compensation, who pays if it harms someone. Termination risk, we talked about that. He stresses you need political scientists, governance experts, ethicists deeply involved in these conversations, not just climate scientists. It almost makes you wonder sometimes if solving the climate crisis itself might actually be easier than solving human cooperation on this kind of scale.
That's a sobering thought. And beyond the high-level global politics, we absolutely have to consider the direct human impact, particularly for indigenous communities. They're often on the front lines, already facing devastating changes from the warming we already have. How is climate change hitting them now, and what role, if any, could geoengineering realistically play for them?
Yeah, the impacts are already drastic, especially for indigenous peoples in the Arctic. We're seeing melting ice, much shorter winters, huge changes in biodiversity. All of this directly hits their essential traditional activities, whaling, fishing, sealing, reindeer herding. They're literally losing land to erosion and rising seas. Travel across ice, which was vital, is becoming incredibly dangerous. Just look at Arctic sea ice. It's been retreating at something like 10.7% per decade since the mid-90s. It's staggering.
Yeah.
So in this context, some people position solar geoengineering as potentially a way to buy time. Yeah, slow down the warming processes, maybe stabilize things like sea ice for a period. The idea is this could give these communities more time to adapt, maybe even allow them to continue some traditional ways of life while we work on the bigger, more permanent solutions like decarbonization. However, and this is critical, we have to come back to the risks. Unilateral geoengineering, one country just deciding to do SAI or marine cloud brightening on its own that poses huge risks for other regions, it could cause disastrous environmental effects elsewhere, which just underscores, again, you absolutely need global collaboration and agreement if you're ever going to deploy this stuff. This isn't just some abstract scientific puzzle. It has profound, immediate consequences for people's lives and cultures.
Absolutely. This whole deep dive revealed some truly ingenious, sometimes startling ideas. But alongside that ingenuity, there are just immense scientific, ethical, and geopolitical challenges. Hurdles everywhere you look. And it seems crystal clear, despite how intriguing some of this sounds, the overwhelming scientific consensus remains. The number one priority, the main focus, has to be rapidly, drastically reducing greenhouse gas emissions.
Exactly. That has to be plan A, B, and C. These SRM ideas, some seem relatively low cost, maybe even ready to deploy fairly quickly, technologically speaking. They do offer this potential pathway to slow down warming, maybe buy time, like we discussed. And it's a huge, but they demand unprecedented global cooperation to manage all those risks we talked about, to avoid terrible unintended consequences. It really is a double-edged sword, a potential short-term tool that opens up this Pandora's box of long-term complexities and dangers.
So it leaves us with a really difficult question, doesn't it? Given the sheer urgency of climate change, but also the staggering scale of these governance challenges, how might humanity ever actually agree on controlling a collective global thermostat? Is that even possible? Or will localized, maybe smaller scale solutions like those brighter roofs or protecting specific reefs be our only truly viable path forward for any climate interventions beyond just cutting our emissions? It's a lot to think about.